these pools, you can connect as many Elasticsearch and OpenSearch clusters as you want. Once you have more than 5 clusters, you're going to see some sort of a bar at the top that will let you sort through clusters. We've just added a feature that lets you group clusters into sort of folders. So you can basically say all clusters that belong to this department or to this tenant or anything like that, you can group them together. And the whole premise is to, if you notice, we're not showing the cluster health, for example. I don't care about the cluster health. Is it yellow or green or red? If the cluster is red, you're going to see an alert here because it says something. There is something that you need to act on. Or if it's yellow, the same, just with a much bigger threshold. But I don't care if the cluster is yellow or red. I care about the health assessment for it. And if you click on the health assessment, you're going to see that we're looking at 4 pillars: stability, performance, resiliency, and security. And then we do a lot of checks here. And then, for example, if the indexes are not even, we're going to tell you why, which ones, and why are they not even. So basically, there is an index pattern, and the index pattern has indexes under it that are not even. And then we're going to tell you that you want to migrate this index from daily indices to rollover in this case, because we think it makes sense. If it's daily and it's uneven, you definitely want to do that. If it was even, by the way, we would still recommend that because you still want to do that. It's a best practice, but it would just not be highlighted as a warning or as a relatively high severity. It will be basically lower severity. So all of those checks will formulate some sort of a score. And if you have dozens of clusters, you can just see the scores and you can just understand which one went through a degradation, like you see here. So you can see the history. So you can see some degradation. And that degradation will tell you, what happened and why and what you can do with it and so on. Now, for example, I mentioned security before. You can go to one of those checks and you can just say, I don't know, the course is enabled, I did it on purpose, everything is fine, I know why I did it, and then you can go and ignore the check. And then basically, look, the score is fine. You can look at the score, you can say, this score is fine for me, I know what I'm doing, 70 is fine, all I need to monitor is that it doesn't degrade. But what we did even more than that. We can get you to get that to 100. So if you go and implement the recommendations, so you can see all the recommendations here, set high refresh rate on large indexes. So we tell you what exactly command you need to run. You can do this on CORL, of course, and then you can go and create a ticket directly to your team to implement it. Once it's implemented, it will be automatically resolved. So you can see all the ones that have been resolved. And then, once it's resolved, if it affects a health assessment check, your health assessment will go up. So you need to go and implement whatever we're recommending. However, if you think that you don't need to, you're happy with what that means, you can go and ignore the check. Once you ignore the check, we basically help you to get to 100 score. And then on large scale, when you have hundreds or thousands of clusters, it's going to be easier for you to track what's going on, because you can just look for the greens or the yellows and so on. The concept of what this platform does is it's a platform essentially. So Elasticsearch and OpenSearch we support right now. By the way, this integration wizard, you can see everything that we support. OpenSearch, Elasticsearch, Amazon OpenSearch, and Elasticsearch. So basically, it's Amazon OpenSearch service, and then Elasticsearch older versions are still running on it. So we support it. We support Elastic Cloud. Then we ask you to fill in the cloud ID. And this is a homage for the old versions of Elasticsearch. So we also actually have customers running Elasticsearch 1-point-something and 2-point-something, and they're using the platform and they get tons of value from it. We keep urging them to upgrade, but it's not that easy sometimes. So we have that. We're also allowing to, not on this one, allowing to monitor Kibana. So in a lot of our customers' platforms, Kibana is a critical component. So we also allow that. And since you asked, I'll also tell you that in about just a few weeks, we're going to release Logstash monitoring. So a lot of our customers have fleets, essentially, of Logstash instances. it's not really clusters, but it's more fleets of Logstash instances with pipelines and everything. And we're going to release all the product features for that as well. So basically,
how is that different than the regular monitoring that you can do through an Elastic cluster, a regular one?
You do have it, but think about all the insights that we are able to provide for Elasticsearch. We'll also be able to provide it for Logstash. Yes, it's less interesting, but it could still be interesting in cases. For example, I don't know, a pipeline has degraded once its configuration has changed. We can tell you that. Instead of you looking at dashboards, we'll just tell you that. And that's what we do, right? And just to give you an example, this is our main screen for the overview. Let me quickly refresh it because I did expect something else. Seems to not work. So this is the AI summary. You should have seen here, demos will always fail. You should have seen here the AI summary of how your cluster is doing. Basically, it's going to write to you, the cluster is doing this and that. I'm happy with it. I'm not happy with it. Let's look, maybe the other one. It doesn't work. Interesting. But basically, we show you all the interesting metrics, and you can look at that over time. So if the cluster was connected to the platform 3 months ago, you just see how it's been going for it since it was connected. So, same number of nodes, documents, and suddenly there's a drop in indexing rate, for example. So you can actually see and you can pick and choose, any of those metrics, all of those core metrics, basically, that you'll be monitoring holistically. So you can see that all here, and that's that. Then we're telling you if there's any unresolved alerts, any repeating alerts. And that's where it starts to be interesting, because a repeating alert will actually have something, it will mean something, right? If you have a repeating alert. Now, remember, this is a kind of a demonstration cluster. It's not a real workload, so there will be some weird stuff here and there, but this is something we see a lot. So an alert that keeps occurring, right? And you would want to somehow figure out how to fix it. So if we go to events and alerts, you're basically going to see the alert timeline. So you're going to see, in this case, high search queue, sometimes multiple nodes, sometimes specific node has been recurring. This is Elasticsearch. This is OpenSearch. If we look at OpenSearch in this case, you're going to see like a little bit of a different behavior. And then if you have a lot of alerts, you're going to be able to filter them. And then those alerts will get you a lot of information. So again, let's look at the high search queue, for example. If I'm going to click on one of them, you're going to basically see everything I have to say about that alert. So high search queue or node, search queue is accumulating, and it tells you exactly what happened and what is the impact, and then any next steps that we recommend to do. So for example, if we think there is if we have a reason to believe there is high long-running tasks, and I don't know, a search queue or search task that is running for a long time, will actually highlight that to you and tell you to kill it. Sometimes we're able to see it ourselves. Sometimes it's a more generic idea, but this is the idea. So we're going to give you, we call those action blocks, and it will explain what needs to be done, and then demonstrate on how to do it. I don't know if you noticed, I'm speaking about the platform for, 10 minutes now, and I didn't mention the word dashboards even once. We have dashboards. We have the best dashboards out there for Elasticsearch, I can promise you that, but it's not what we sell. What we sell is this kind of, you as an SRE, if you had a high search queue and somebody would call you up and tell you, I need you to look at that, everything you see here is what you would have been going to do manually. So we did it automatically for you. We actually identified what's going on and what is the impact, and then we tell you, what are your options. Now, sometimes we'll be able to tell you this is the right option, but as you know, sometimes there's different options and you need to choose. For example, I don't know, low disk space. Do you remove all data, or do you make a bigger disk or add another node? I mean, it's a decision you have to make. We'll show you what we think needs to happen, and then you can make up your mind. But we'll give you all the context. So that's that. So and speaking about dashboards, we have those dashboards. So this is OpenSearch, cluster nodes, indices, KNN, shards, and queries. On Elasticsearch, we don't have KNN, unfortunately. There's no dedicated API for that, so we cannot monitor vector search performance. It's just a standard query in Elasticsearch. And OpenSearch actually does it a little bit better on that front. And on nodes, as you can expect, we basically can see, all the nodes, every information you can have. We have a metric of our own. It's called write pressure and search pressure. It's basically a calculated metric. It's one of those things that we do. It's a calculated metric that tells you if there's been any point in time that the search pressure per node has been very high. You can see that the ultra warm here node is actually the ones that's been peaking. So the pressure on the ultra warm, the searchable snapshots on Amazon, this is the ultra warm nodes, has been peaking, and you basically can see everything. So as opposed to Kibana monitoring, you can see all nodes in one place, right? We also provide this kind of cool functionality, so you can enlarge that. You can kind of dig into any. You can immediately add filters. Again, the best dashboards you can find for Elasticsearch, OpenSearch, machine stats, network, everything you can think of basically is here. We have a lot of nice tricks. For example, the load average. How many times did you want to quickly switch between 1 minute, 5 minute, 15 minute? So we have it here quite easily. So you don't have to make any changes over there. Same thing for, caches. We do a similar thing. So by default, we show the ratio because this is what's important, the hit miss ratio. And you can see, hit miss ratio of 2% is quite bad, right? But you can actually see how it looks like. So it's a derivative, obviously. Same thing for request cache and fill data and all of that. So those are the nodes. Similarly, on indices, we also have a couple of nice things that we do. So what we'll do automatically, we group all indexes by an index pattern. So you can quickly sort, sort and change the sorting based on any metric on the index pattern level. So you basically can quickly understand the behavior pattern, right? I mean, what do I do with this cluster? Okay, I'm indexing a lot of, I'm ingesting a lot of logs to this one and less to this one, and then it goes down from here. Or I'm searching which ones I'm searching more. So very easy to understand that. And obviously, you can quickly know the specific indexes as well. Yeah, so we have that. All of those are the ones. We automatically group all the internal indexes, so you don't have to care about them, and then all the indexes that are not within any pattern, and all of this is identified automatically. So it's not something you need to configure. So I didn't show everything. So we have a Heatmap or a Treemap here, so you can quite easily zoom into so you choose which metric you want to sort this by, and sometimes visually it's easier to kind of understand which one in terms of search takes the most heat, right? Or if you want to sort this by storage space, you can see that you have two patterns that are basically, equivalent, and then it's sometimes very easy to look at it this way. So we have that. We have shard heat maps. So you can see the non-tiered nodes and the ultra nodes in this case, and you can kind of understand. Here you were showing if there's any imbalance in terms of search, or if there's an imbalance in terms of indexing, which we do. It's kind of expected, to be honest, but you can see that. And then this is on the nodes level, and then you can quickly jump to the indices level and see which shard is the offender in this case. So for example, here quite easily you can see from this graph that maybe this specific index needs to have more shards, more primary shards, because it would balance the writes better, right? So this is kind of thing you can see visually very quickly. And then obviously the platform would create this kind of recommendation automatically, because again, if you can see it visually, you can describe it also programmatically. So we have that. I mentioned KNN dashboards. The same thing is for Elasticsearch as well, except from KNN. We do have a query analytics feature. It's not enabled on those clusters, unfortunately. But out of the box, you're going to get, maybe we will see a couple. Out of the box, you are going to see the slowest queries that we automatically detect. You don't have it right now. And we call this sampling mode. So basically, you will see the actual slow queries for any query that takes above 30 seconds. I think it's a decent threshold. And we're sampling that and to show you the queries that are slow and 30 seconds or more.
Yeah.
There is a way to basically ship all the queries to us, and then we're also able to do fingerprinting. So basically, automatically understand which queries belong to the same family of queries because they were created or generated by the same code or screen, and then based on that, tell you what would be our recommendation for it. Maybe the Elastic. I think we don't have it on those clusters, but we have a couple of customers who have been using it, and we're able to find quite interesting patterns. And so again, those are things that I don't think anybody offers anywhere, and we do have it. So unfortunately, I cannot demonstrate it right now. But again, you'll see the slow queries. You can see the full list as well, and then you actually be able to see the fingerprint and any insights that we have on that query or that query family of queries. The cost optimizer essentially is we're on the Elastic side now. A cost optimizer basically is to us it's another view of the same data, right? So on the health assessment, I'm looking at stability, performance, resiliency, and security, because that is the maintenance toil. That is where the risk is. That is where you would want to get, let's say, significant understanding of how your cluster is operating and how to improve that for either your teams or your customers. Cost is a lot of recommendations we're going to get you around stability and performance are going to be the same, but also we could be able to affect performance. So for example, indices sizes are even. If we are going to have a recommendation about moving to data streams, and it also relates to some extent also to cost. So when you go to the cost optimizer, we're going to basically automatically generate the current cost and with an asterisk. We don't really know what your cost is, but we can estimate, right? We can see how many cores, disks, memory, and so on. And if you're on Elastic Cloud, we know what the cost is. If you're on EC2 or any managed service, if prices are public, we're able to derive. So it's not necessarily your real price, but it's pretty close. It should be pretty close. And we're going to break this down for you, what the costs are. And then we're going to basically suggest, usually we suggest one or two different cost plans, and we give them a name. So in this case, aggressive ILM and consolidation versus some savings that are more conservative. And we're going to show that to you and basically say, we don't see a reason for you to be on an Elastic subscription that is high. And masters, you definitely can maintain what you have right now, but we recommend that you move away one hot node and move data to warm tier. So warm tier usually are cheaper, and you can do that. Keep the frozen tier. You have an ML node, you can keep it, but you can eliminate the coordinating nodes, right? And then change any storage, and then basically, we just saved you $1,000 in this case. A more conservative approach would do something a little bit different, and it will just say, in this case, and it is the reasoning, but basically keep the coordinating nodes, but reduce them, and don't do any changes to the tiers themselves. Similarly, and you can see the optimization insights here, and we can kind of show you we'll obviously go with the bigger number because it's cool. And we can, on OpenSearch, definitely running on Amazon, we can do similar things. So for example, you don't have frozen, but you have ultra warm, and obviously we look at that as well. That's the cost optimizer. One thing we are not doing at this point because it's a little bit more tricky, but we will get there. It's a clusters running on Kubernetes.
Okay.
There's a lot of clusters running on Kubernetes. Elastic did a great job with this ECK, the Kubernetes operator for Elasticsearch. We are, as a team right now, working on helping OpenSearch, the Linux Foundation and OpenSearch release a Kubernetes operator for OpenSearch, which is actually production safe and actually tested. Once we've released that, we're going to do two things. One is we're going to see more people using OpenSearch on Kubernetes as well. And we'll need to figure out how Cost Optimizer reflects that, because I don't know what your cost on Kubernetes is.
Okay.
But we are still talking about cost in terms of resources. So we'll need to figure that out, and we have some ideas, and we will reflect that. So when a cluster runs on Kubernetes, we know it. Yeah. And this screen will look a little bit different. And the second thing we're going to do for OpenSearch, we are going to allow smart auto-scaling through polls. So essentially, you will be able to run OpenSearch on any Kubernetes cluster. It's open source. And the operator will be able to basically consult with Pulse if you are a subscriber of Pulse and get some instructions on how to do it. And then you can basically whitelist the operator what you allow it to do and what not. So again, this is still in very early stages, but that's also something we're going to do.